Use the figure above to find the length L of the square and the required shortest distance. Let us solve them. Label O, B, C, D and E join O, D equals O, C equals radius of the semicircle. OB equals 6 subtracted from R. Consider the given 45 degrees right triangle BED. Area equals to 72 square centimeter. Also, area of 45 degrees right. Triangle BED equals the square of EB divided by 2. Since EB equals B, D opposite side equals adjacent side for 45 degrees right triangle. This implies that area A equals 72 equals the square of EB divided by 2. Cross multiply and solve for EB. Take the square root of the equation to give that. Opposite side equals adjacent side for 45 degrees right triangle. From triangle BOD. Using Pythagoras theorem, we have that the square of OD equals the sum of the square of BO and BD. This implies that the square of R equals the sum of the square of the difference between R and 6 and the square of 12. Expand bracket, simplify, rearrange terms, and we have the product of 12 and R equals to 180 divided the equation by 12 and we have that. R equals 15 centimeter, which is the radius R of the semicircle. From triangle EOA. EO equals the difference between EB and BO, which is equals to 3 centimeter. Simplify and hence EO equals 3 centimeters. For question I, let us solve it. HO equals to sum of L and 3. Using Pythagoras theorem for triangle GOH, we have that the square of GO equals the sum of the square GH and HO. Substitute values, cancel equal but opposite terms, and we have equation form in L. Expand bracket, simplify, rearrange terms, and we have rearrange the terms of the equation form in L in one side of the equation. This is a quadratic equation, and so we can solve using general equations as shown on the screen. Here, A equals 2, B equals to 6 and C equals to negative 216. Substitute coefficient of terms and simplify to get the value of L. By substituting the values of A, B, and C and simplifying the value of the radicands of the radical, we have the value shown on the screen. Take the positive value of L since we are measuring length. Simplify the value of L to have that 36 divided by 4 equals 9 cm. Therefore, L equals to 9 centimeter. For question 2, label small red circle center as K, another point W and join K, W. Notice that the red small inscribed circle is tangent to or it touched the square at all sides so that the product of 2 and R equals L, which is equals to 9 centimeters. Divide the equation by 2 and we have that R equals to 9 divided by 2 in Join KO and consider triangle KOW. Use Pythagoras theorem and we have that the square of KO equals the sum of the square of KW and the square of WO. Substituting values, simplifying, and we have that the square of KO equals to 306 divided by 4. Take the square root of the equation after simplification and we have that KO equals to the product of 3 and the square root of 34, all divided by 2 in centimeter is the required shortest distance between the center of the semicircle and center of red circle.